Well, welcome everybody, and thank you for joining us on today's webinar. My name is Jarrett Ryan, and I am the ABB Brand Manager at Amber Technology. Hosting today's webinar is Ian Harding from ABB Australia. Ian is the KNX Product Manager and a certified KNX tutor. This is actually the second in an ongoing series of webinars co-hosted by Amber Technology and by ABB. And you'll find the recordings for these on the Amber Technology YouTube channel. And as we bring more webinars to you, you'll find them distributed in the Amber Tech newsletters as well. Today, we're diving into the features and benefits of DALI lighting control and how it integrates with ABB. DALI is very common in commercial deployments and growing in popularity in the luxury home market. DALI is a big topic, so this will be a two-part webinar. The first part is for anyone designing, selling, and commissioning DALI systems. The second webinar will pick up from where we left off, and we'll go deeper into the commissioning side. So this is a 1-hour webinar today, including the Q&A. And then we ask that please that you drop your questions, if you have them, into the Q&A panel, and Ian can go through them at the end of the presentation. So with that, I'll hand over to Ian so he can get on with it.
Thanks, Jared, and good afternoon, everybody. Great to see a good turnout today. Thank you for your time. It's not always easy to get people. I understand we're all busy. So I'll try not to waste too much time. As Jared said, my name's Ian Harding. I am the product manager for ABB Smart Buildings. Today, I'm going to talk to you about DALI gateways, and I've quite a packed agenda here. So I'm going to move on, and I'm going to actually probably go quite quick. So my agenda is as follows. I'll give you an introduction to sort of KNX and DALI technologies. I'll give you an overview of the iBus DALI gateways. We look at briefly at emergency lighting, how we deal with emergency lighting and what we can do with it. Then I want to show you a bit of the functionality of our DALI gateways. We have quite a broad range of product, and it's important to know the difference between them, what each benefit can bring you, and what solutions we have out there. Following on from that, I'll give you a brief introduction to the iBus tool for diagnostics and DALI addressing. As Jared said, we'll move on to our second webinar in a couple of weeks, and we'll look more at how this works, how to use it, and I'll set up a system here and we can play with it and we can get it working. And lastly, but not least, I'll just give a brief introduction to sort of DALI communications and diagnostics. What do we do when we have a problem? How do we look at a DALI line, and how can we manage it, essentially? So quickly moving on, an introduction to DALI. So DALI technology is around quite a while at this stage. So we know the DALI protocol is standardized by IEC 62386. And it's actually quite a slow bus. It only broadcasts at 1200 bits per second. So we often see DALI lights will give us sort of like a Mexican wave in a room. When we turn one on, then turn the next one on, then turn the next one on. We get sort of a Mexican wave in features. And there's ways around that and how we can get around that. And what we do then is we can create 16 groups. So we can create a group of DALI lights on our DALI lines, and each one of those groups can be managed in up to 16 scenes. DALI, of course, has evolved over the years like all other technology. And in DALI 1, when it was first released, we sort of had a single master-slave system without collision control with a maximum of 64 devices on a DALI line. Now we have DALI 2 out. Now DALI 2 has enhanced this quite a bit. And now we have the ability to have multi-masters on a DALI bus with collision control. Again, we have 64 devices with a maximum of 64 controllers on the line. The installation is really simple. It's a free wire topology with up to 300 meters length and non-polarity sensitive 2-wire cable. Many of you who've put in a DALI bus, it's really quite simple to set up and wire and lay out in a building. There's nothing really special about it. The one thing you have to manage is that the voltage at the devices should be no lower than 12 volts. So if you have quite a long run, it's always recommended to measure the DALI voltage at the end of the line, and just to make sure that some devices aren't dropping off the line or losing communications or having difficulties. And inevitably, of course, then we'll have a DALI power supply sitting on that line, and each device can consume a max of 2 milliamps off that line. So the most important DALI devices that we see today are sort of DT0, which are standard fluorescent lamps. We have DT1, which are self-contained emergency lighting. We have DT6, which are LED modules, and DT8, which are color control and temperature control fittings. You can see I have the standard sort of mapped up there. You can go onto the website, the dalialliance.org website. You can read all the details if you like reading all standards. But all these details are there and anybody can look at them at any time. And of course, when I talk about DALI and I talk about DALI and DALI 2, people tend to get a little bit confused about the differences between them. The real difference between DALI and DALI 2 is DALI 2 has advanced the standard to a level where it's quite a good standard now, and all devices must be certified, whereas previously, when DALI was originally released, it was a self-certification, and what that meant was different manufacturers are doing different things with their DALI control gear, and invariably this led to some problems. What's happened now with DALI 2 is that we're guaranteeing compatibility between components because it's certified now by the DALI organization, and to do this, we build a new device, we send it off to the DALI Alliance, and they then go get it tested and certified to work to the DALI 2 standard. Saying that, all of our main gateways have all been registered and certified as DALI 2. You can see we have a DGS 16451, DGS 26451, a 16411, and a 26411. And they're all certified to DALI 101 and 103. Why do we look at DALI and what's the advantages of DALI? Well, DALI is a very successful way of controlling lighting to get good dimming, to get good information back from your building. Some of the larger projects we've done, I mean, I was involved in some of the terminals in Heathrow Airport, things like that. So when you have those large projects where you have thousands and thousands of lamps, you do need a good way to control them. And with the advantages of the DALI system, where we can look at the status, we can get feedback on lamp and ballast failure, we can implement various light effects with color control. It gives us a great way to know what's happening in our building. And when we integrate that then with our KNX system via our KNX gateways, we really have a great way to manage and control both systems in a building and simply and easily work them and make sure our building is totally under control. So DALI gateways generally act as the master on the system, and they'll transfer commands from KNX to DALI. And we'll also receive a status back from our gateway as well. So the KNX DALI gateway is really doing cyclical queries onto the DALI line and cyclically talking to all the devices. So we'll look at the status of a lamp. So pretty quickly, we'll know if there's any problem with any fitting or any ballast on that line. Two things to note. One is that the ABB iBus DALI gateways are single master systems, okay, with an integrated power supply for up to 64 devices per line. And other DALI masters and DALI power supplies devices must not be connected to the DALI output because it will interfere with the communication. I've seen now there are some new DALI fittings being released that sort of they can set up their own little DALI network in a line, and by default, they actually have the DALI power supply enabled on these fittings. Do not connect these back onto our DALI gateways, as it will cause confusion and trouble on the line. You can't have two DALI power supplies and two DALI masters on the line. Typically, here's what we'll see. Just let me get my pointer. So to the left-hand side here, we have our KNX line. Here we have our KNX DALI gateway. And in the gateway, we have various levels of control. We can broadcast to all DALI devices. We can individually control all the ballasts. Now there's 64 ballasts on the line. Just be careful because these ballasts in DALI land are numbered 0 to 63, whereas as in our world, the real world, we number them 1 to 64 because it really doesn't make sense to have a DALI ballast 0 or a DALI lamp 0. It confuses people and people tend to get confused by that. So just watch out for that mismatch between the two systems. Typically, we can set up a group control, so we can define all of these ballasts and we can drop them into any one of 16 groups. And rather than controlling each lamp individually then and sending commands for each lamp, we just turn the group on and off and we manage the group. And also we can make these devices part of a light scene. So if we have any light scenes and we want to implement different functionalities through our building, we can trigger the light scenes as we want. On the right hand side then you can see our DALI ballasts, our DALI lamps, and you can see they each have an individual address. So they have their DALI short address. They'll also have indications of what group they may be part of and if they're part of any scenes or they're involved in any scenes throughout the project. So that's really a real quick overview of DALI and why we need DALI. Next, let's have a quick look at an overview of the ABB iBus KNX DALI gateways. So our history of gateways goes back a long time to 2006 when we had our DGS11, and that was really our first good DALI gateway out that we had. There was 2 channels on this device. On channel A, we had full control over all the devices on the line, individual control on each device, and DALI B was just a channel B was just a broadcast line. This was then supplemented in 2009 when we brought out the 116.1, which, as well as having individual control of all 64 devices, meant that we could now sort of set up lighting groups, and we can control by groups rather than individual address. In 2012 then, we launched the DGNS, which brought in emergency lighting control as well. And it meant that we could control and talk to DALI emergency lights. From then we had the DGS 8.1, which is still a very useful device today. It's an 8-channel device with up to 16 devices per channel. But what we actually do is we control the lighting per channel. So I switch channel A on and off. I dim channel B up and down, etc., etc., etc. One huge advantage of using this device is, okay, we only have 8 circuits, but if we have a small office or we have a small building, we can manage it quite easily. The huge advantage is there's no DALI addressing required. We are switching per channel, we are dimming per channel, and we are controlling per channel. So it makes control really easy. On top of that, we have the DLRS 816.1, which is our DALI constant light controller. And we also have the DLR A4811, which is a surface mounted unit for decentralized DALI solutions. So you may have places where you later need to add in DALI gateways or need to add in more DALI fittings, and you can't wire the whole network back. There's certain places where it can be hard to add in extra devices. So you can use one of these connected to your KNX network, and we will then have full DALI control of whatever light fittings you connect to it. When we look at our main DALI gateways nowadays, we have the DGS 164 and the 264.11. So the difference is it's a 1-channel device and a 2-channel device. Each channel, of course, supports up to 64 devices. They support the normal device type 0 and device type 6. So we're talking usually about emergency lighting, or we're talking about standard fluorescent lights or standard DALI ballasts. So with these devices, then we can have any mix of match or groups or individual control, whatever we want to do. It's supported by the iBus tool, and we've a great programming support called templates. And I'll just give you a brief introduction to that later. And of course, we've all the usual stuff like turn on brightness, basic brightness, partial failure scenes, etc., etc., etc. So these are quite powerful devices, and they can do an awful lot for you in a DALI system. The premium devices then add in extra functionality with color temperature control. We have RGB, we have dim to warm, human-centric lighting, and standby switch off. I'll look more at these functions later, but for now I'm going to keep it pretty high levels. So for all of these devices, we have a supply voltage between 100 and 240 volt AC, which is connected on the bottom of the device. There's an integrated DALI power supply for each, so we don't have to add a secondary. With some systems, you have to add a secondary DALI power supply onto the line. We don't need it. And also very useful is the DALI outputs are protected against 230 volts. There's always wiring mistakes. People make mistakes, and we know that this happens from time to time. So the actual outputs are protected against this, and it makes sure that if you incorrectly or by accident connect 230 volts to the input to the output, well, it's not going to blow up the device then. All the devices have a manual test button on the front, and there's 2 LEDs on the front for on and DALI fault. So quick and easy diagnostics. When you first turn these on, you will see the lights flashing and blinking as they address the line or they check all the fittings on the line. And it's a quick way of diagnosing what may be wrong or what's happening with your DALI line. Always have a look at the manual. The manual will tell you there's different types of blinking with the LEDs. It may have a fast blink or a slow blink. Always check these first. It's always a good place to check. We have the unique commissioning, of course, with the iBus tool and fast application download via the IP routers and the USB interfaces. Here's a table now. It's a good table to show all of our devices and what's available. Shows every feature. It gives you a good idea of what you can do with all the devices. You'll get a copy of this later, so you'll be able to keep this and use it for reference. Typically, when you're commissioning, there's a few commissioning steps, and it's usually quite quick. So if the electrician has installed the system and everything is installed and ready for you guys to come in and start programming, well, a quick press of the manual operation button on the front of the device will turn every fitting on that line on or off. And it's a good way to check that electrically everything is connected correctly. Of course, then we'll go into ETS and we'll set all our parameters, we'll program, link, we'll put group addresses, however we want to do it. And then, of course, we just download the application. We can then use the iBus tool to parameterize DALI. Using that, we can readdress devices, we can create groups, we can check what's happening on our line. So we have all the features that we need to do. And then we can always adjust things in ETS after and download to the devices. As I said before, one of the main checks that I advise everybody to do is to go and check the DALI voltages on the line. So if you put the DALI gateway, you need to put the DALI gateway into manual mode first. So if you do it while the DALI line is functioning normally, of course, it's sending ones and zeros on the line. You're going to find the voltage will be flickering all over the place. If you put the gateway into manual mode, it halts communication on the bus. So the voltage on the bus is steady and can be measured with your voltmeter. So typically, of course, you should have about 16 volts on the line if you've no problems. If you're at the end of a long line, it could be 13, 13 and a half, 14 volts. If it's lower than 12 volts, you're going to have an issue. You really are going to have issues. Possibly you have a bad connection, or possibly your line is too long. So you should always check that, and always check it at the furthest end. And always remember, when you have disconnected the DALI line from the DALI gateway, there should be 0 volts measured on the line. If there's a voltage measured, then there's another DALI power supply somewhere, and we should fix that. It really needs to be fixed. We can't have it there. If you do want to find extra information and you want to read all the manuals and stuff, you can go to abb.com/knx, and when you go in there, you'll find all lighting control information, webinars, etc., 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 and all the product manuals and all the product details. All the stuff is in there. Next thing I want to quickly show you is emergency lighting and how emergency lighting functions. So the DALI emergency converter is, again, according to IEC 62386, and it's to do with self-contained emergency luminaires. So what our DALI gateway can do is we can send commands to the DALI, to the ballasts, and we can query them and ask them, and it gives us such flexibility that we can use one system now. You think again of going back to say Heathrow Airport, you're talking about huge airports, big buildings like this. If you have one system installed that can do all your emergency light testing and control your building and give you full reports of what's happening in your building, it just makes life so much easier. In commercial projects, it gives the building manager such an easy way to overview and oversee his whole project and make sure his building is operating correctly. The DALI emergency lighting, we don't provide any functionality in terms of emergency lighting. So we don't log any sort of functions that are stipulated by local laws. What KNX DALI Gateway does is it gives us an intelligent mediator between KNX and DALI. But what it enables us to do is to take all the information from the DALI system here, via the gateway to a head-end visualization. So we can perform a lighting test, a battery test, or any sort of those sort of tests we need to do. And the information can be fed back to the database and the visualization, where all the information about the tests that have been carried out can be recorded for later analysis. And I mean, typically you look at a self-contained emergency kit like this, and you know, you have a battery, you have your DALI connection, and that's about all there is to these guys. As I said, in the higher level systems, you know, we have program software like NetX Automation, we have iSpare, and using these software systems, it's easy to configure a database to run your emergency light tests. You can sequence them, you can run them when there's nobody in the building. You know, back to the old days when you had to pay an electrician to come in late at night or come in on a Friday or Saturday, flick a break or sit there and just record and make sure all the emergency lights stayed on as long as they were supposed to. Well, that's not the case anymore. We can ask the system to automatically do this for us. So we can perform all the mandatory tests for emergency lighting, and we can control it from a KNX device. So I can write a simple sequence to test a whole floor, and I can say, okay, test room 1, test room 2, test room 3, sequence the whole lot through the building to ensure that we don't put the whole building into darkness together. So we can go and do all the tests. We can set everything up in KNX. We can install our head-end software on a PC somewhere talking to the whole system, and we can configure and control as we need it. So the tests, of course, are on the basis of the IEC standard. And so the tests we do are, we can check the functional test of the lamp, which looks the correct operation, and we can check the switchover device for an individual battery just to make sure everything is there with our function test. So the function test will do a quick test. It's like a 30-second test on each device, just to check the electronics of the device, to check the lamp is there and the lamp's operating okay, and check the device switchover for the individual battery. There's no battery there, we get an error. Of course, the next test we can run for all these is we can do a duration test. So of course we can say, just run the duration test and see how long it takes for the battery to go flat. Always remember, of course, nowadays, a lot of these battery emergency light packs are running LEDs. And this test can take hours and hours because an LED pulls such a small load. It's not like years ago where we had a small fluorescent or we had an incandescent lamp or whatever we had. Now we have a small LED, and these LEDs can last a very, very long time. And of course, we also have the ability to run a partial duration test, which isn't part of the standard. Now, I might say, okay, let's test them for 3 hours just to make sure everything works okay for 3 hours, because we know they're LEDs and we don't want to sit there for 15 hours waiting for the whole system to perform its tests. We can run a partial duration test just to make sure that everything's working. And that's the sort of things that we do with the emergency lighting. We can do the function test, the duration test, the partial duration test. The whole system can run these automatically, record everything back into a database, and then present a report. And those reports are gold dust to people running buildings. They love these things. Now I just want to have a quick run through the functions of the DALI gateway. And this is important because there is a lot of software and a lot of functionality into these devices. And it's important to remember, we won't know them all. We won't be experts in everything. But if we know they're there, we can take the manual out, we can have a quick read, and we can understand quickly what's been done there. First thing to note is that when we go and look at a DALI gateway, we can parameterize 64 individual lights. Now we can set the parameters for these 64 individual lights all differently. We can have the status, we can have the fault, we can look at its functions, we can look at timers, we can RGB, we can look at all these different functions. And I guarantee you, if you're doing this, it's going to be mind-numbing and boring, and it's going to take forever to do. That's why we've designed a template. So I can now design a status template. So I can use this status template. And for example, I could say for a group, for a ballast group, I'm going to set a minimum dim value of, I don't know, 10%, 20%, 30%, whatever. I can set a max dim value. And every fitting then that's part of that group and is part of that template, that's how its status is. You do not have to do anything else. I can change the turn on brightness. So if I change the turn on brightness in here, apply it to the template, it's applied to every fitting that uses the template. And it really makes programming quick. If I look at it here, you see on this side here, I've my group 1. I've set up my DALI group in my parameters. The group 1 status is applied from the template. So whatever templates I have defined in here, it will stick to it. If I change it, if I change the template, it changes for all the groups that's attached. It's really quick and easy. The opposite is I then go individually. Okay, we may need some fittings for some groups who may need different status or different whatever, different fault or different functions. We may just be slightly different, but by and large, when we're programming big projects, we don't do it individually. We apply a template to all of our light groups, and this saves us a huge amount of timing. When we create scenes now, if you remember, I said how we have 64 devices on a line. We can put them into 16 groups. We can also gather them into scenes, and we can activate them through scenes. So for each device or ballast in a group, I can choose to make it part of a scene. So I've set up scene 1, and I now on my DALI line, here's the different devices of a group 1, 2, 3, 4, 5, 6, ballast 5, 6, 7, 8. These are all available to me on the DALI line. I can tick here to make them part of the scene. If they're not part of the scene, I don't tick them. If they're part of the scene, then I set up my parameters here and what I want the scene to actually do. So it's a nice and easy tabular way to figure out what we want to do with our scenes. I can also apply a turn off brightness. So, you may have a corridor during the day, there's windows down the corridor, it's bright enough. And you might say during the day, okay, all lights go off, there's nobody in the corridor goes into darkness. However, at night, you might decide that, okay, at night it's dark in this corridor and I don't really want people seeing dark corridors in the building. So I can say my turn off brightness at night is maybe 20%. Okay, it's dim. People walk down the corridor, the lights will come back up to acceptable levels, but we don't need to have the lights on fully all the time. And that's the point. We can save energy by doing this, and we can automatically program this and parameterize it, and we can figure out what we want to do with it. The other side there is in car parks. It's specifically applicable to car parks because, there's a lot of security issues in car parks of people, especially women, walking into car parks in their dark areas, and they have to walk down the car park until a presence detector sees them and turns on the light. Why not have a turn off brightness which sends them at a minimum level so the whole area isn't dark? It makes complete sense in something like that. We also have partial failures. So if in an area we have a number of lights failed, we can say, okay, we've had so many fails, turn on these other lights. We can control the level of illumination in the area by looking at what's failed. And if stuff has failed, okay, we can turn on the lights that are remaining at 100% to make sure there's enough illumination. When you think of places like staircases and things like that, you don't want darkness over a staircase. So if you have lights failing, turn all the other lights in the area on full so people have full visibility, and it's another safety issue. We also have forced operation, and I see things like forced operations typically used for a cleaner will come into a commercial building at night. They may have a key. They have a key that they put into a key switch, turn the key switch, all the lights are on, and they can quickly see everything in the building. When they're finished, then they turn off the key, and the key turns off all the lights in the building in one go. Very simple and very easy. They're the standard DALI gateway. If we look at the premium DALI gateway now, you may remember I showed you earlier, all the functionalities we now bring in are to do with colored RGB, HSV, dim to warm. All the color functions for the DT8 light fittings now come into the premium gateway. And when I look at things like that, I look at it supports color control switching of device DT8 to there's your standards. So a lot of these ballasts have multi-channel color control with RGB capability. And it means you can mix the colors and produce any color you want. Yeah. The only things to remember are you need to make sure you have the correct application program. Always look out, especially when programming ETS, From time to time, there are bug fixes. From time to time, there's software updates released. Always make sure in a new project that all your software is up to date. You get all the functionality and all the bugs are out of your system. What is RGB? Well, I think we know what RGB is. It's red, green, blue. And then we just mix a percentage of each to give the color that we want. And that's a very common way of controlling lighting. After that, we have HSV, which is hue, saturation, and value. So from the hue, we get the value determines the color shade and is on a 360 wheel. So if you think the hue is going around the circle on the top, we're picking what color we want. When we look at the saturation then, the saturation is fully saturated if it's pure color. If white's added, it becomes more pastel. So as we go up and down the saturation, in and out from the middle of the circle, the color will change. It'll dim, it'll add more white to the color. And then we have the value, which sets the brightness. And if we drop the value, it just gets darker and darker and darker. And when we look at color control, HSV is really the best way to control colored lighting because it's preferential for the way the human eye perceives colors. Okay, so if you think of places like I'm thinking of art galleries or museums or places like that, it's really important to get the correct colors into the space and to make sure everything's okay. We don't want to have our nice Picassos on the wall with a hue red all over it or whatever. We want to make sure it's nice and that it works nicely for the building owners. So typically with RGB and HSV, it gives us total color control over all the fittings. And it means we can do anything we want with them. We make them any color, any shade, any hue. And it just means that we have perfect control over our DALI lighting. And then when we look at it, how do we achieve it? Well, it's quite simple. I mean, we have our screens, we have our different touch panels, and using these touch panels, we program then, we can change the hue, the saturation, and the brightness. We can go into these panels and we can get sliders and dragging. We can create scenes with different light colors. We can do what we want, but it's all typically programmable. We just program it and we send the values to the gateway. The gateway then controls the DALI itself. Really easy. Next topic is to look at the color temperature control. And you'll know this from, typical ranges between 2000 Kelvin and 6000 Kelvin, depending on the ballast and the lamp. So from this, I mean, we think of a warm white, think of a old type incandescent lamp, which was always a warm type. It was always sort of an orangey hue to the lamp. It was lovely and it was always relaxing. But now with LEDs, we can really get a cold white, which is very bright, heightens your awareness, wakes you up, all that sort of stuff to get you energized and working. And there's two examples now. I mean, the same room with different colored light gives you a different perception of what's the room for. Would you sit in a room at 6,500 Kelvin watching TV? It's bright, it's horrible, you wouldn't want to do it. At 3000 Kelvin, it's a warm white. It's probably a nice, comfortable room to sit in. Another feature we have is dim to warm. And dim to warm is really based on how the old incandescent lamp, as I said, used to work. And the idea being in an old incandescent lamp, you have it powered up fully, you dim it to the max at 100%. It's really quite a bright, harsh light. But as you dim it down, we introduce sort of redness into it, and it gives us that sort of comfort and relaxation in a room. And LEDs typically won't do that. I mean, you dim an LED up and down, it's a harsh white, and it's always a harsh white, whether it's at 100% or it's at 10%. But the dim to warm functionality now allows you to manage that sort of comfort in the lighting. So if we dim the lights down, do we need the harsh light? No, for dimming lights down, we need comfort. And that's exactly what the idea of the dim to warm is. So we're changing the color of the lamp as we're dimming it. So it gives us more comfort. So you think of hotels, bars, restaurants, you think of in the morning, you think of all these sort of places. You don't have a bright, harsh light in here. You don't need it. It's made to be comfortable, and that's what we want it for, and that's what the dim to warm will give us. And typically you'll see this is what's going to happen. As you dim the lamp, the light, of course, gets more warm. You dim it up, it gets brighter and it gets more cold. It gets sharper. Certainly, if you're cleaning the place, sharper light is better. You can see what you're doing. If you're sitting watching TV in the evening, the warm white is much nicer, much more comfortable to sit in. So this is what the functionality does, and this is how it works. So it'll dim it. You can set the parameters for the lamp to vary from, say, as I said, from 20% to 100% over a color range from 2000 Kelvin up to about 6000 Kelvin. And this then leads us into human-centric lighting. And when you think of human-centric lighting, think of sort of sunrise in the morning as your ready, lovely summer's morning. You get to 12 o'clock in the middle of the day, you have bright, bright sunshine. And then in the evening, you get the dimmed red light again. And, you know, we're creatures of habit, and we're around thousands of years, and we're used to this sort of flow of light, and it's to our human-centric, and it aids our feelings. Nobody wants to sit in a bright, harsh light all day, 24/7. If you can mimic this in buildings, well, then you're sort of onto something. The building becomes more comfortable for people to work in. And the principle is that in the morning, we start off with a warm white. Through the morning into the afternoon, then as we get to midday, the light becomes a cold white, becomes sharper. And then in the afternoon, of course, as we move into evening, the color temperature moves back down to, moves back down to the warm white. And you think of a solution like this, say, for a classroom, you're trying to focus kids, you want kids to pay more attention, you need to wake them up, Typically kids will come in, they've had lunch and things like that, and you want them to wake up, you want to keep them awake, and the lighting can help you do that. And I've also seen a few projects lately where they've put the human-centric lighting into healthcare facilities, and they're using this sort of to make the patients feel more comfortable in the building. Patients can be in hospitals for a period of time, and it's nice for them to see sort of lighting that sort of mimics the outside world and sort of it makes them a bit more comfortable. And you can see, patients with dementia and other disorders in particular are sensitive to the loss of daylight. You often hear in Europe of people going, SAD, the seasonal syndrome, where in winter it's dark too much and you don't get enough daylight. We can now use this to make people feel better in buildings, and we can give people better feelings. Another thing, of course, we could do is easily program sequences. So, we have sequences, bars and restaurants, shop buildings, places like that. We can run a sequence, and the sequence then can just change color slowly over time, and we can run a repetitive sequence. And, you see some buildings in some of the big cities have external lighting doing this all the time now. It's really quite nice. So we can run a sequence with RGB, HSV, we can run color temperature, we can run brightness values, and we can run sequences sequentially, whatever way we want to do. It's set up in a similar way to scenes. You have that table, you can add the devices in, you can add the groups in, you can do what you want, you can pick the colors, and you can see what time it's in the sequence, how long it lasts in the sequence. And you can just run the whole thing from start to stop. You can run it through once, you can run it through multiple times. You are in control of what you do with the sequence here. Applications for sequence, of course, as we started, the human-centric lighting, and then color control and color sequences and fancy lighting outside buildings. There's all that sort of stuff we can do with these. And very handy thing as well is the operation duration. So for a lot of ballasts nowadays, we want to know how long has the lamp been running. Do we just guess that the lamps have all been on for like 3,000 hours, 5,000 hours, 6,000 hours? We're going to relamp the whole building. Well, we can now get you a value, and we can now get you a report detailing the duration, how long the lamps have been on for, how long the groups have been on for, and what we've done. It's a great idea. It's a great way to manage things like that. Another energy saving thing is the standby switch off function. So If you think of all these thousands of lights you may have in any building, think of all these ballasts you have sitting there, and these ballasts are all sitting there consuming energy, even when all the lights are off in the building. And there could be thousands of them. It might be only, as it says there, 0.2 of a watt or something, but add up 10,000 of them in a building, and suddenly you have quite a big load there. What we can do with the gateways now is we can activate the standby switch off. So what the standby switch off will do is we can use it to kill the power to the DALI line altogether. So all the DALI ballasts are actually powered off when all the lights are switched off on the line. And a few things you got to know about is that the DALI gateway would really think of a ballast power or a ballast fault when it doesn't see the ballast, because remember, it's continually polling the line. If it sees a ballast fault, what are we going to do? Well, because we're using the standby switch off, it suppresses this alarm too. So it enables us to use it. How does it work? Well, some lights are switched on, so there's no standby possible. If we get to after a delay, if all the lights are switched off and after a programmable delay, we can send a telegram on the bus, and the telegram then will turn off the switch actuator, which kills power to the DALI line. Simple as that. And it does the same in reverse. And nowadays it's really quite quick. People have this doubt that I switch on a light or a presence detector detects me coming in. You're talking half a second. You're talking at max half a second for the relay to come back on and for the DALI gateway then to turn the lights on into the room. Really, it's not an issue, and it's a great way to save energy in a building. So that's really a quick, very quick run through a lot of the functionalities built into the devices. Now I just want to briefly talk about the iBus tool. As Jared said earlier, we will have another webinar and we will follow up with this and look more into how this operates. But really, the iBus tool is a programming tool that sits on your laptop or your PC, connects via the KNX line to the DALI gateway, and gives us control and information from the DALI gateways. So what we can do with the iBus tool, you see it here on the left-hand side, it detects all the devices connected to the DALI line. It will give us the address of them all. If I want to readdress a device, I can just drag and drop it wherever I want to. Over here on this side, we have all our DALI groups. If I want to add a device to a group, I can select a group and drop the device into the group. There's other functionalities here that we can do with it, but I'll show you all this later. So it's really a great way of looking at our DALI line and seeing what's happening. We can go and look at a general. I mean, the front page, the general page on the front straight away gives us an idea of what's happening. The power supply is okay. Everything's okay. We've 20 devices monitored. There's no conflicts, no faults. In a snapshot, we can see what's happening on our DALI line. I can go into the DALI and I can readdress. I can look at the devices. I can see what's happening with the devices. I can select individual devices. I can select individual groups, and I can play with them. I can tune them. I can have a look with them. I can check the operating hours on the device. So all this functionality is available and it's easy to do. Last thing that I'll quickly show you is the search ballast function is a really, really handy function. If you've ever walked into a room and you know there's a DALI ballast above your head, but you don't know what number it is or what fitting it is, search ballast will quickly, in 6 clicks, you will find out the address of that device. Again, it's very simple, very easy, and I'll show you how that works next time. Just quickly then, I talked a bit about DALI communication, and this I think is my last topic. DALI communication on the line. So diagnostics are, it's really handy to get these tools, and if you are programming and you have problems, to be able to see what actually is happening on the DALI line. Of course, in ETS, we can connect via the KNX line to the DALI gateway. We can look at all the telegrams on the bus. We can see what's happening on the bus. But you should also get a USB DALI interface. And from that side, we can sit on the DALI line and we can see what's happening. We can monitor the actual the DALI telegrams. Are the telegrams happening? Is the device replying? Have we got issues going on the line? There's numerous manufacturers of these, and You know, you can get them, you get their software, and you can just sit and see all the queries and commands and whatever's happening on the line. It's really, really, really useful. So DALI commands and cyclical queries. DALI will typically query every device on the line. It continually queries each device on the line, starts at device 0, then checks device 1, then checks device 2, then checks device 3, etc., etc., etc. It gets to device 63 and starts again. So it's continually polling the line for the status of the lamp, for the status of the fitting, just to make sure everything's okay. It's a never-ending loop. It just keeps pinging the devices. There's the different commands you'll see on the DALI line. Here's what you can actually see. So you'll see query status going out to the addresses. So address 59 is a query status, no reply, no reply. You get this device number 1. We look and see what's happening. We get to device number 0. We get to broadcast, set fade times, broadcast. You can see here what's happening. When you send a query, you get an answer. You send a query, you get an answer. You send a query, you get an answer. It allows you to see exactly what's happening on the line if you have an issue. Something I have seen over the years, and this is just a quick thing, occasionally I have seen where the DALI devices can't respond quick enough, or maybe the line is a bit long, whatever like that. There is a way in the DALI gateway to put a pause between the queries. So if you look here, there's a 2-second pause between the 2 queries. We can lengthen that if we need to, just in case, to see, is there a problem with the line? Are we not getting responses in time? Is the line too long? Is there some issue on the line? I had an issue many years ago of a manufacturer said we were polling the devices too quickly. They wouldn't respond quick enough. So the fix to this was just increase the pause between the query status. It's important to know, and occasionally you may see it that you have DALI communication issues. This can be a way to fix it. Not saying that it will get around wiring problems or other things like that, but it's something to bear in mind. And again, there's the various different replies you can see from the device. You can see, we'll know if we have a ballast fault, a lamp fault, if the lamp's on, if there's an error, if there's a fade running, a reset status. So they're defined. Those different statuses are all defined, and we can see what's happening on the bus when we look at it. And you can see most of the common commands. You'll see them on the lamp. You'll see the arc power level. So you're telling a lamp to go on 100%, and you can see that command going out on the line. And you can see transitions. You can see go-to scenes. So it's all the typical stuff that you should see on the line. One thing to watch out for is a framing error. A framing error will exist, and you will see that. We will see that actually on the iBus tool as well. If your line is too long, if there's a voltage problem, if we can't communicate properly with the device, if there's something wrong with the communications on the DALI side, typically you'll see a framing error. There's problems with telegrams. There's something just not right on the system. You will see a framing error. If you see the framing error, have a look at your line. There's something not right on your line with your wiring or something like that. Okay, it's just 10 to 4. I've got through a lot of stuff today. There's a lot of information there, but I tried to briefly touch on everything that we have available. If you have any questions or queries, we can go through them now. Over to you, Jared.
Thank you, Ian. Terrific job, very detailed. Look forward to our second part of this webinar. We'll take a bit more deep dive into practicalities and some commissioning. And so thank you again for everyone attending. We have one question there, Ian, in the Q&A.
Yeah.
What are the pros and cons of doing the fixtures or ballasts grouping from the DALI gateway or at KNX bus level? Which is better and more efficient? And what is the impact on the KNX traffic? It's a 3-parter if you want to have a look at it.
Okay, let's break it down. The advantage, I can group them on the KNX side. So I could say, I can have one group address in KNX and I can switch on, say, fittings 1, 2, 3, 4, 5. Okay. That's my grouping done on the KNX side. So one group address does the grouping, fires the fittings on and off. On the DALI side, I create a DALI group called, say, group 1, and I add those 5 fittings into that group. So I now have group 1. So the 2 examples are, if I turn that on using the K and X groups, I'm going to have 5 commands go out on the DALI line. So I send a command out for lamp 1 on, I send a command out for lamp 2 on, I send a command out for lamp 3 on, I send a command out. And in bigger installations, there might be 20 fittings, there might be 30 fittings. You will have a delay between each one of those lamps coming on. However, if you use the grouping on the DALI side, you send one telegram from DALI side, turn on group 1. Every device on the DALI line hears that, and any device as part of the group turns on instantaneously. So it's a much quicker way of turning on bigger groups. And the same with turning them on and off. It's the same for off. If I turn off the group on the DALI side, bang, they will turn off altogether. If I do it from the K and X side, I have to turn off lamp 1, then I turn off lamp 2, then I turn off lamp 3, then I turn off lamp 4, and there will be a delay with all the lamps going off. And that's why it's probably better in a lot of cases, not always I'll give, but in a lot of cases, it will be better to group them on the DALI side. Does that answer?
Brilliant. Thanks for that, Ian. No, that makes perfect sense. All right. Well, with that, we'll wrap up from here. That's the only question we have in the Q&A. So thanks again, everybody, for joining us today. Keep an eye out in our newsletter for the next webinar in this series. We'll catch you on the next one. And Ian, thanks again for hosting.
No worries, and thank you very much, everybody, for attending. Goodbye.
Bye for now.